So we're going to look at this proof for law of sines. Right here is law of sines. And what we do is we start with this triangle right here. Do you notice that angle A has side A opposite of it, angle B has side B opposite, and angle C has side C opposite. And what we did is we drew a height in. All right, this height's important to create a non-right triangle to all of a sudden be two right triangles. And so what we notice here, for this right here, sine angle A is h over b. Well, sine angle A is opposite over hypotenuse. That's the first statement. Next one is saying sine B is opposite over hypotenuse. So we have these two statements from the picture. We have one triangle here, one triangle here. We're ignoring C for now. Then, what they did here is they multiplied both sides by B. So if you simply multiplied both sides by B, and over here you multiply both sides by A, this goes straight down, and you got those. Now, from this step, what you hopefully notice for each of these is they both equal h. And if they both equal h, can you go and replace this with h? Or replace h with it? Since this is h and this is h, can't you go and replace that? And now you have this statement. Next, how do you get from this statement to this statement? What they did is they divided both sides by a and b. So it's kind of hard to write, but what they did is they divide this side and this side both by a and b, and you jump into this. And there you go is law of sines. Now you might wonder, well, what about sine c over c? Well, to do sine c over c, well, you have to make a whole new height. Maybe a height right there. I drew that wrong. But you have to make a new height and do it completely different using c as an angle instead of a and b. So for this particular setup, you can't find sine c over c as being equal, but it is. So really, what this formula really is also, you could technically add, you could add sine angle c over c is also equal to all these if you were to choose a different height to build in the middle of your triangle.